And before I get started with the presentation, please put your names in the chat so that I know who's exactly here for the session. All right. So for the presentation today, we'll just be talking about conditional rendering, controlled components, and forms in local React. We'll just start with this presentation to cover the core ideas, and then we'll be moving on to the coding examples just so you can see how these concepts work in practice. All right, so this is kind of like the agenda for today. We will start with conditional rendering, then talk about local versus application state, and then we will talk about controlled versus uncontrolled components. After that, we'll take a look at the controlled update cycle, managing forms, and then confirming user input before we move into the coding examples. So the goal for these sessions is just to try to understand the concepts and get like familiar with it, and then we will take a look at what they look like in actual React code. So let's start with conditional rendering. So conditional rendering in React just means showing or hiding parts of the user interface depending upon some condition or state. And here are some common operators that are used to implement that condition logic. The first operator is this ternary operator, which is usually denoted by a question mark and a colon. The ternary operator is useful when you want React to choose between two different things to render, like one element if a condition is true and another if the condition is false. And then another common operator is the logical AND component operator, which is usually denoted by two ampersands or AND signals. It is useful when you only want to show something if a condition is true, and then if a condition is false, React does not really render that element. So, in this example, if there are any unread messages, React just shows the message count. Below that, in the below lines, the ternary operator checks again if the number of unread messages is greater than zero. It just shows a message that says time to get reading, or else it will just show a paragraph that says no new messages. So the main idea is that React lets us make the allows us to make the interface respond to data dynamically. And then now that we've looked at like conditional rendering, the next question that should be really important is that where our data should be live. And there are two different states where this can be where data can be stored. The first is the local state. So local state is data that belongs to just one component. A simple way to think about it is like a personal sticky note on your monitor. Only that component really needs it. And then some examples include whether a drop down menu is open or closed, or the current text inside search input. And then another state is the application state. It is shared across different parts of the app. You could try to think of it as like a bulletin board or a central whiteboard that multiple people can read from an update. And then some examples of data in the application state include authentication status, shopping cart items, or just your general theme settings. So, in general, Local state is great for smaller UI specific tasks because it keeps things simple. Application state is better when multiple components need access to the same data or when that data needs to persist across the line. So the main goal, the main goal is just choosing the right place for data so that the app stays easier to build, debug, and scale. So let's try. So the main question. So let's think about this for a second. So when a user types into a form, where does the value actually live? So that in React, that we usually describe that as the source of truth. And then so in a controlled component, React the current state the React state would be the source of truth. That means that the input's value is directly tied to the state, often using the use state reference, and React updates that value as the user types. This is useful when you want like instant validation, or you want to implement some conditional logic, or when the input value affects other parts of the UI. Similarly, in an uncontrolled component, the DOM itself, now the DOM refers to the document object model, it holds the current value. This would work more like plain HTML, and React can read the value later often using a reference when needed. This can be used for simpler forms, file inputs, or cases where you will be integrating with non-React code. So the big difference between the two components is who is in control. Uh, in control components, React state is in control, whereas in controlled components, the DOM would be in control of the input values. Now, let's take a look at what actually happens step by step in a controlled component. So, for an input to be controlled, it needs two things: a value prop and an on change prop. The value prop tells React what should appear in the input, and the on change prop tells React what to do when the user types. So let's try to go through this process step by step. That is on the right side of the screen. In the first step, the user would typically type a key into the input, let's say R, and then in the next step, that would trigger the on change event, and then in the next step, the event handler would runs and updates the React state. For example, maybe it could try to search for values starting with R, and then in step 4, React would re-render that component using the updated state, and it would display the new value. So the important idea is that React manages the input state. The component state is it would be the single source of truth, and UI updates after the state changes. The predictable flow is one of the main reasons controlled components are so useful, especially when forms tend to get more complex. Okay, so now let's try to talk about really complex forms that have like very multiple inputs and multiple form fields as well. So when a form has that, creating a separate use state for each field can get repetitive very quickly. So in that case, a common pattern would be to store all the form data inside one state object. This keeps the code cleaner and makes the form easier to scale as you add more fields. The first part of the pattern of this particular pattern would be the state object. That means values like username and email are stored together in one object. The second part is the name attribute. Each input gets a name that matches a key in the state object. And then the third part of that of the pattern would be a dynamic handler. So instead of writing a different on change function for each and every input, we could use one handler that updates whichever field changed by reading the event.target name. And then in this example, and then this entire pattern has been shown in the example on the right. The initial state has two properties, username and email. And then inside the handle change event right here, we will just pull the name and value from the target, which usually points to the input fields. And then we update the state by copying the previous state and replacing only the field that matches the input name. So if the user types in the username box, only the username changes. But if they type in the email box, only the email would change. So this pattern becomes very useful because it reduces repetition, and it works well when you are when you're taking in much more when you're taking much more inputs than just the username and email as well. But we now that we have an idea of how to manage form input, the next step is making sure that the data is actually valid before it becomes part of the application state. One thing that you should always consider is that you should never trust user input. You should always try to validate it before it becomes like a main part of your application. And then a helpful way to think about is that the user, while the user is typing, the form is holding like a temporary working copy of the data in the local state. And there are two strategies that would help us validate the data. The first strategy would be early returns. That means simply adding a check inside the on change handler, so that if the user input is invalid, we could stop them right there and we do not update the state with any bad values. And then the second strategy is like a dirty check. So that usually means using a Boolean variable like is dirty to track whether user has changed anything or not. That is useful for things like only enabling a save button when there are actual changes. So in the example on the right, uh, there is a profile. This is a typical function for our profile editor. It keeps track of both the error, both the bio text and an error message. So when the user tries to type in their bio, the handle bio change would event would read the new value. If the bio, and we have also set a limit of like 100 characters. So if the bio is longer than 100 characters, it sets an error message and returns early. Because of that return, the invalid value never gets saved into the bio state. And then if the value is valid, the error is cleared and the bio state is updated normally. So the takeaway from this would be to try to validate early and prevent bad data from entering the state, and track whether the user has made changes before allowing them to use. Okay, there's also another useful form pattern would be the confirm and cancel pattern. This helps prevent accidental mistakes by giving a user a chance to review changes before those changes before become permanent. It's kind of like when you want to like leave an unsaved work document, and then You just get an alert like, are you sure you want to leave without saving your changes? This pattern is almost similar to that. So the key idea here is we keep a temporary working copy in the local state while the user is editing, and we keep the original saved data in the application state until the user confirms. So right here, the editing profile would kind of be like the excuse me. The editing profile is the working copy. As the user types into the form, they are only changing the that temporary version. The original user profile would stay unchanged in the main application state until the user clicks save or confirm. If the user confirms, we would push the working copy into the main application state, and that would be the current user profile that we have at the moment. If the user clicks cancel, we discard the temporary changes and we could just reset the form back to its original version. And this is exactly what it would look like when you would in React code when you would try to add and edit functionality. So the component starts with by creating editing profile from user profile with the use state yeah. So the handle confirm function calls the onSave method with editing profile, which means that the edited version gets sent back to the main app state, and then the handle cancel function resets editing profile back to the user profile so that any unsaved changes are thrown away. So this pattern is helpful because it clearly separates editable draft data from the final saved version, and that also gives users a safer editing experience. So, to summarize what has been covered so far, the conditional rendering helps us build dynamic interfaces by showing different UI based on data or state. We also try to talk about keeping state as local as possible and only using shared application state when multiple parts of the app need access to the same data. And for forms, components are often the better choice because they make validation and more complex logic easier to manage. We also try to take a look at some efficient patterns like using one state object and one handler for multiple fields, validating input early, and using confirm and cancel patterns to protect the user changes. So let's see. So eventually mastering once you get used to these patterns, you will see yourself trying to build you will see yourself building more maintainable and robust React applications. And the only way that you would get used to these patterns is if you practice often. And with that, I'll just take this time to see if you guys have any questions at all. All right. If anything comes up, please if there are no more no questions for now, that's totally fine. Let's go ahead and try to move into coding examples. But if at any point you feel like asking questions, feel free to either post your questions in the chat or just unmute yourself and ask me at any point of the demonstration. So let me take another moment to try to share my screen. Okay, so we just try. So right now I've just prepared some examples. These will of this will of course we will be building on examples from last week, just so there is no confusion. I will try to walk by each example step by step, so you can see how the concepts from the slides show up in uh, in actual React code. So for this example, we if you were there last time, this is just the same group of students, and uh, this is the first example is kind of like a simple student list app, and it helps us review several core ideas from React together, like state, arrays of object, event handling, and rendering UI based on interaction. So in this app component, we have created this array of students. That's just sample data, and then this use effect does not this use effect that we have does not have a dependency array, so it will be running after every render. this is just uh, this is just trying to you know uh, help you review some of the concepts from last week as well. And in this and then for the second effect, this has an empty dependency array, so it would only run once right after the component has been mounted first. And then we have inside that use effect, we just log if the app has been mounted and unmounted. And then for the handler, uh, we define a function called select student that takes in a name, and the line inside it uses a ternary operator to if the student that was clicked is already the select student, we would set the selected student to null, which by then deselects them. Otherwise, we would just reset selected student to that student name, which would thereby select them. And then we would also try to log which student was selected in line 34. So that helps us trace what exactly is the handler doing here. So up to this point, this file was just setting up the student data, tracking which student was selected, and watching the particular renders with use effect, and then defining the behavior, uh, click behavior for selecting and deselecting the students list. And then this is just the GSX code that helps that is like has the main element that is acting like the outer container for the whole app. And then the styles are defined inside the style prop, and then we have added in different components which we'll be revisiting after a after once we've taken a look at the main app component and the shopping component. So let me just take a moment to run this application. Okay, so this is our This is our student roster that has been rendered in the browser, and then each student has been displayed as a card. If I try to select it, then you can see that this selected student comes up on top. But if we try to select it again, it gets deselected. And also, I have also added some conditions to check if the array of students actually exist. So if I just pass an empty array of students instead of the student roster that we just saw, we would effectively see we should be able to see nothing except this particular student because this has been added right here. So since Marcus has been added like a property, so that is why his card is still visible. But if we had to just check and see if there is any array passing yet, and so that is part of the uh, conditional conditional programming that helps us make the application more dynamic. We just take a moment to completely set this back to normal. And there is our student roster. Okay, so let's take a look at the other components, and then we will also try to see. Okay, so let's try to visit this component like line by let's try to take a look at this component. Inside the counter function, you will see that we are using use effect from React because this component needs a state and a side effect. And then we've also using a variable called count, which helps us store the value, and we are always starting like 0. And then the input value is the controlled input that will be stored separately from count. That separation will be important because it lets us validate what the user types before we decide to update the actual count. So this line helps us create that input value, which will be taken from here. And and then for the dirty state, we just use a boolean variable called else form dirty. It tracks whether the user has typed something into the input, and we will be checking whether there are unsaved changes. And then and then we always have a use effect, which will be tracking what the count was. If the count is 0, then the appropriate log statement would be made that a counter was mounted and it shows the starting count. Otherwise, it logs the count has changed to the new value. So up to this point, this component is just setting up three pieces of state: the saved counter value, the current text in the input, and whether the form has unsaved changes. It also uses use effect to watch and count and log whenever that value changes. And this is just and then if you remember from our previous weeks, this is the two helper functions that show an important React idea about state updates. And then if and this is the add to broken inside. If we try to set count plus one like two like twice. So at first glance, it does look like it should increase the count by 2, but in React, state updates can be patched. So both lines may use the same value of count. And then because of that, This version often increases the count by one instead of two. And then in the fixed version, instead of directly accessing the count variable, we use the update form. This that tells React to use the latest state value each time. So the first update adds one, and the second update adds one again to the already updated value. So this version increases the count by two. I realized that this was discussed in the previous weeks, but I just thought that it would be a good idea to revisit this concept. And now let's try to take a look at the input handler called input change. Uh, this function runs every time the user types into the input field. This line stores the current input text in a variable called value, and then the next comment explains the validation goal. We also want to make sure that we do not add like any negative values or non numeric input. So if we find any such values, we just set the is form dirty variable to true. And so the this part of the component is just doing like two things at once. It is demonstrating how React state updates work, and it starts showing how controlled inputs can be validated before we commit the changes. And these handlers helps us push the local input value to the count, which would be like the application state, and then for the confirm, we would this function would run when the user confirms the change, and event dot prevent default, which is denoted by E. It stops the browser's default form behavior, so the page would not refresh after entering any input values. So this line just checks whether this line checks whether input value is just an empty string. If it is empty, the function just returns early and does nothing. If there is a value, then we would update the count by converting the input value into a number using input parse int, and the 10 in the other parentheses just means that we are parsing the number in base 10, which is the normal decimal numbers that we use in everyday life. After updating the count, we also set the is form dirty variable to false because the change has now been confirmed and saved. And if the user wishes to cancel the value that has been updated, we would also have a handler for that as well. It sets the input value to nothing, and it sets the is form dirty to false because we are throwing away their temporary change instead of saving it. So these two functions are a good example of the confirm and cancel pattern. And then this is just the GSX component, which helps us with setting up the buttons that we see on the screen. So let's try entering any non-numeric value. So you can see that I have tried to enter E, but there is no option to set the count directly since that is not a valid number. And then if I try to add a negative number, you can see that it's not letting me do that because, as I said, React does not let me confirm that value as the new value. And then if I try to enter a negative number, the same idea applies. That input should be rejected because it does not meet the rule that we have set to for valid input. So let's try to set the count to add 23. So if I confirm that, our count will be directly set to 23. And if I try to cancel this, you can see that even after we have entered 46, the count variable still seems the same. So That separation between draft input and save state is exactly what makes controlled components so much more useful for forms. And then, last but not least, we do have our shopping list component, which of course which starts with the list of the list of groceries that you might need, and then we I and for this particular example, we have also tried to control the input. Let's see if I wanted to add like chicken to this list. So we would be able to add that item, and this confirm and cancel would help us either confirm this chicken to the list, or if I had to type in, let's say if I wanted soy sauce, and then if I click on cancel, you will see that it gets completely removed from this particular list. And so when I type something like any of the grocery items in this list, and then I add it into the list, I'm not immediately changing the confirm list forever. Instead, what I'm doing is first updating the temporary version of the data, and once I click on confirm, that draft change gets saved into the confirm list. Once I click on cancel or reset, that temporary change gets thrown away and the list goes back to the last confirmed version. So this is another example of separating working state from saved application state. So this pattern is really helpful here because it gives user a safe place to make edits before they commit them. It also shows why React state updates should be done immutably, because when we add a new item properly, we create a new array instead of directly mutating the old one. Now, let's take a look at at this code right here, which helps us understand. So let's try to connect the behavior to what we just saw on the code line by line. And then this is our shopping list function. Here, the items and set items are already created with useState with the values milk, eggs, and bread. And then this is our current local, this is the saved version of the data. And now working items is another piece of state. This is kind of like the local working copy, which while the user would be editing. So it also starts with milk, eggs, and bread. So at the beginning, both lists would match. But then, as we add items, you will notice that the grocery items that would get added will get added onto working items instead of items. And then the is form dirty is kind of like the variables we saw in the earlier components, which helps us track whether the user has made changes that have not been confirmed yet. And then we have also added an input ref, which this reference would be attached to the input so that we can directly read its current value. And then this is the function where we try it's here to show what not to do. So if we try to push butter directly into the existing array, it would be added, but uh, it would not be uh, the right way to go, because in React that would not be the recommended pattern, and then state should be treated as immutable, and then the items just sends back the same muted array reference, which could lead to unreliable updates. And then this is the function that helps us handle what exactly you should the correct approach to adding items to cart. And then the line the it reads the current text from the input, and it trims for extra space. And then if and we also check if the value is empty or not. If it's empty, we return, and if it's not, we just go on and add it to our working copy only, and not just the application state. And then this prevents just blank items from adding being added. And then this line and then so since this is an immutable update, which would be so this is one example of how you could add items to cart while updating arrays in state. And then if the form is not marked dirty, we can always we could set is form dirty to true. That tells us that the component there are now like unsaved changes in the working copy. And so this code is what makes the draft edit behavior possible. So new items would go in the temporary working list first and only get confirmed later into the saved list. And then this is our confirm and this is just another example of the confirm and cancel pattern that we have seen back in the counter component that we had seen before. And this function just helps us set the list back to the original milk, eggs, and bread. And then this particular piece of code helps us to see if, to show the current shopping list. And also you will notice that there is a ternary operator added right here, which just shows that if the list is empty, there should be something that's added. So if in case if we try if we don't show like the bread, milk, breads, and egg, so let's try and do that. Let's try and see what happens. And if this does happen, hmm, okay, so if the list is empty, this is where our list, this is where we get the message like your list is empty, add something, and that is how we try to make our application more responsive to the types of data and the length of the data. It all depends upon the conditions that you want to set, and that is all the I think that's all the coding examples that I had for now. Does anybody have any questions about any of the about the presentation or any of the coding examples that we just went through?
One question. Is dirty state line 43 or 49, I believe? Is that like they go 29? I do see in 29.
Okay, in 29. Okay, yeah.
Is that like a built-in function? Not is a form dirty. Is that a built-in function or?
So that is not a built-in JavaScript function by itself. So is form dirty is just a way is just a state that we have set up at the top. It does come from React's useState hook. So it just gives us it just helps us understand whether it just helps us stores the current value, and then the form dirty is the function which is used to update the temporary value. I hope that makes sense.
Yeah, so are you importing, if you say uh, it's provided by React, then are you importing anything to use it or?
So the only thing that I'm importing from React is the use state.
Mm-hmm.
And so at the if you can see at the example on the top, we're just using the use state hook. And then once we call the use state as false, it just gives back a pair. So this is essentially a state to to just check whether
Mm-hmm.
user has made any changes in the form.
Okay, it's just a variable, not like
It,
a built-in
yes,
function.
it is a variable. It's not a built-in function by React.
How do you track, by the way? Initially it is false, but when do you set it true?
Okay, so the way that we would set it to true is that we would for now, let's say that the it has initially been set to false, and then when we try to add any items to the shopping cart, we will
Mm-hmm.
first check if his form is dirty. So in this case, we are just checking if the initial variable is false or not, and since the negative of false is true, this will help us set the is form dirty to true, and which helps helps us understand that their user has made certain changes and they have not been confirmed or saved yet.
Mm-hmm. So when a new item is added to the array, then you're trying to make it to true. And when are you resetting it to false?
Yeah, so the only way where we are trying to set it to false is when we try to confirm or cancel whether we want to add something to the cart. So let's say if I want to add chicken, so right after clicking the add item here, our is 30 form variable would be set to true, and once I confirm or cancel changes, that
Uh-huh.
will help us set the variable to false again.
Oh, got it. Okay. So whenever you click either confirm or cancel, then you reset the value, like the boolean
Yes,
value.
that value is reset to false. I hope that answers your question.
Yeah, that answers the question. So don't we have any built-in functions in React that tracks the form is dirty or the something like that? No. This serves the purpose,
Um,
but I'm just asking.
Yeah, yes. In terms of finding some functions built in React, I would have to say no. But React does give us use state, but it does not automatically provide a tracker for forms. So if you want to know whether a form has say, unsaved changes, we would
Mm-hmm.
usually create that logic ourselves with
Mm-hmm.
something with some while importing use state.
Okay, got it. Thank you.
Karnik, I had also similar confusion, which is like, okay, besides setting the values true or false in the form is form dirty, how does React know, like, okay, now is the form is dirty, it has to, uh, I mean, if it's true, what exactly happens when it's true? Like, w- I mean, the purpose of is form dirty is um so that the React knows, right? It has to update. I mean, I
Okay. I think I understand your question. A React. So one thing that so for this particular case, the isform 30 is nothing but a Boolean variable. So React would always and another thing to consider is that React would re-render whenever there are any changes in state. So when we set the is form dirty variable to true on line 29, React sees that state changed from false to true. So once React sees that changes, it would re-render the component. But React is not thinking this is a dirty form and I should do something special. It is only thinking, all right, this component state has been changed. So let me try to re-render the component again. So the purpose of is form dirty is for the developers so that we can understand what exactly is going on. It gives us a way to store information about the form, specifically whether there are any unsaved changes. And then during the next render, we should be able to use that value however we want. So for example, if we had set is form dirty to true after adding any items to cart, we might show confirm or cancel buttons. Or instead of confirm, it could also be a save message, save button. Or we could also show a message like you have unsaved changes. So React updates because the state has changed. Is form dirty just gives us a meaningful piece of state that we can use to control the UI or the form behavior in general. I hope that answers your question.
Yeah, yeah, that does. Yeah. So, so one thing that I felt like, okay, so shouldn't it be used in the use effect? Like if the form is, well, we are tracking the list, if we should update the list or not based on if based on this Boolean variable, right? It's not for um whether it should re-render or not, right? Because then it should have been part of use effect, right? Which kind of does that automatically
Yes.
render. Yeah.
Okay, so that is actually a really good question. So for this particular example, we do not need use effect because we are not trying to automatically sync the list for whenever the state variable changes. Instead, we are trying to handle it with event handlers. So when the user adds an item to a cart, we update a copy of the cart items, which is set by working items, and then we try to make sure that those changes are either confirmed or cancelled. So use effect would be more appropriate if we wanted some side effect to happen right after the state changes. Like maybe we wanted to save the list to local storage, or we would want to call an API to save those stages, or we could try logging whenever the form has some unsaved changes. So for this example, we are not reacting to is form dirty with a side effect. We are just using it as a flag to control the form behavior and possibly the UI. So since the list update is not happening because use effect is watching this particular state variable, it only happens because our button handlers explicitly decide when to save the draft list and when to discard it. I hope that answers your question.
Yeah, and understood. Thanks. So, one more thing is, did you mention anything about the application state? Like, or it's like this is all local, right? Was there where is the application?
For
Yeah.
Okay, so for now, that's actually so right now the both of these examples are still local state because they are living inside the same component. So when I say like the application state here, I meant it in a more conceptual manner. So, but technically, if you take a closer look at this code, the cart items and the copy of the cart items that are being created are both local to this component because they're both created with use state. The only way it would become application state is if the confirmed list were lifted up to a parent component, and if it was shared across like multiple components or stored in something like context or a state management library. So right now so right now the cart items is just acting like the same source of truth within this component, and the working items right here are just acting like the temporary editable copy. So you kind of right to point it out, in the strict React sense this example is all local state. It is just mainly demonstrating the idea of draft state versus saved state.
Got it. Got it. Thanks.
Hey, are there any questions? Any more questions?
Yes, I have a question, sir. So in one of your files that you demonstrated